Have you ever stopped to think about what it means to be moving, or to be perfectly still? It sounds simple, right? If you're sitting on a park bench, you're at rest. If you're running to catch the school bus, you're in motion. In physics, we say an object is at rest when its position doesn't change over time compared to its surroundings. That bench isn't going anywhere in relation to the ground, so it's at rest. You, sitting on it, are also at rest. But when you chase that bus, your position changes with every single second. You are definitely, absolutely in motion. It's the fundamental difference between staying put and going somewhere. But here's where things get really cool. And honestly, a little tricky. Motion is relative. What does that mean? It means whether you are moving or not depends entirely on what you compare yourself to. Imagine you are riding on a bus, looking at the person sitting across from you. To you, that person isn't moving. They are staying in the exact same spot inside the bus. You're both at rest relative to the bus. But what would a person standing on the sidewalk see? They would see you, your fellow passenger, the entire bus, all zooming past them. Motion isn't just one thing. It comes in all sorts of fantastic varieties. The simplest type is called linear motion. This is just motion in a straight line. Bowling ball rolling straight down the lane toward the pins, elevator going straight up or down. It's moving from point A to point B without any curves or turns. Another example is a sprinter running the 100-meter dash. Linear motion is everywhere, from a book falling off a shelf to a car driving down a perfectly straight road. It's the most basic way to get from here to there. Next, let's get curvy with circular and rotational motion. They sound similar, but there's a key difference. Circular motion is when an object moves along the path of a circle. Imagine tying a ball to a string and swinging it around your head. The ball is in circular motion. A satellite orbiting the Earth is also in circular motion. Rotational motion, on the other hand, is when an object spins around an internal axis, like a top spinning on the floor or a basketball spinning on a player's fingertip. The Earth does both. It's in circular motion as it orbits the sun, and it's in rotational motion as it spins on its axis, giving us day and night. Now for the really fun stuff, periodic and oscillatory motion. Periodic motion is any motion that repeats itself in equal intervals of time. A bouncing basketball is a great example. It hits the ground and comes back up over and over again in a regular rhythm. The hands of a clock moving around its face are also in periodic motion. When we talk about how fast something is moving, we often use words like speed, velocity, as if they mean the same thing. In everyday conversation, that's usually fine. But in science, they are very different. First, let's talk about two other important ideas. Distance displacement. Distance is the total path you travel. If you walk 4 meters east to the mailbox and then walk 3 meters north to your friend's door, you have walked a total distance of 4 plus 3 equals 7 meters. Your legs did 7 meters worth of work. It's the total length of the journey you took, no matter how many twists and turns you made. Displacement is different. Displacement is the straight line distance and direction from your starting point to your ending point. It's the shortcut. Using a little geometry, the Pythagorean theorem, we find that straight line is 5 meters long in a northeasterly direction. The formula is simple. Speed equals distance divided by time. If you traveled that 7-meter distance in 10 seconds, your average speed would be 0.7 meters per second. Velocity, however, is speed in a specific direction. The formula is velocity equals displacement divided by time. In our example, your average velocity would be 5 meters northeast divided by 10 seconds, which is 0.5 meters per second northeast. That's acceleration. Acceleration is the rate at which an object's velocity changes. You know, a picture is worth 1,000 words, and in physics, a graph is honestly worth 1,000 numbers. Graphs are just an incredibly powerful tool for telling the story of an object's motion. Distance time graphs, velocity time graphs. By simply looking at the shape of these graphs, a physicist can instantly tell the entire story of an object's journey. Once you start looking for it, you'll see that the physics of motion is absolutely everywhere. Take sports, for instance. Pitcher winds up and throws a baseball. Technology is also completely dependent on controlling motion. The speedometer measures your instantaneous speed. Even nature itself is a constant display of motion. The planets in our solar system are locked in a majestic dance of periodic circular motion around the sun. It's really about understanding the fundamental rules of the universe. From the tiniest wiggle to the grandest orbit, everything follows these principles. We gain a deeper appreciation for the intricate and elegant way our world is put together. Now that's what I call science.